Thank you so much for being here. I think I have a few guests here today. Thank you for supporting me. So my name is ChangAn, and you can also call me Lea. I'm a first-year PhD student at our School of Information Technology, and today I'm going to share my internship experience at Atomic Cartoons. So during my internship at Atomic, I was working in the 2D pipeline team as a junior technical director. And in the first month of my internship, my mentor has helped me a lot through understanding the work distribution, the workflow of the studio, as well as learning new software and applications required in the work. On the same time, I did some documentation job relating to research and development, as well as the usage of new tools. Well, one of the main part of my internship was a project about facial landmark-based motion capture and its application in 2D animation. The project intends to create a new interaction for 2D animators and the 2D animating process, as well as improving the usability of mocap in animation. So the very original motivation behind the project is that my PhD topic is about motion capture-based animation. And I personally really like animation, so I'm like very passionate about this. And also motion capture is a very advanced technology in the field of animation. However, when we talk about motion capture, many of us might have this impression that this technology is complicated, expensive, and hard to use. However, there's a kind of much lighter weight of motion capture, which is called facial landmark-based motion capture. The idea is by using 2D cameras to trace over human faces features, and by analyzing the motion output of different facial parts, we will be able to understand what kind of motions is delivering from the live action person. And the Adobe Character Animator is a pioneer software in this field, which the software provides a lot of preset 2D characters that could be driven by facial landmark-based motion capture. So, however, one limitation of Character Animator is that the poses are triggered only when the motions reaches a certain threshold, and there's no interpolation between poses. However, after I get started in Atomic, I start to learn the new softwares and the 2D animating software used in the studio. So the software we're using is called Toon Harmony. And according to my supervisors and the mentors, there's a super cool feature provided by the software, which is called Master Controller, which allows user to input different poses for one character and automatically generate a widget to control that character in a very smooth way. And by using Master Controller, we can post a character and create very nice subtle change of the poses with interpolation and very naturally. And also the Master Controller provides different kinds of widget. For example, in the previous slides, that was a grid widget. And also it has slider widget that helps to posing the linear poses. And there's also stack widget that combine the features of slider as well as the grids. So after getting to know this knowledge, we started to think, oh, what's going to happen if we combine facial landmark-based mocap with the master controller? Is there a way to build a connection between the two and send the mocap data to the master controller and automatically control the pose movement, the interpolation of the character through the motion capture? And this is how we originally proposed our project's conceptual framework. And the biggest part of this is, first of all, how to understand the mocap output, how to translate the mocap data into meaningful motions. how to build the connection between the two components, and how to send the data in a way that master controller could understand and make it real time. So starting from analyzing the mocap output, we proposed an animation character's facial expression hierarchical analysis, which consists of 3 levels, where the level 1 is about considering a live action person's facial components as independent component. So we are looking into the geometrical features of eyes, for eyebrows, mouth, nose, to understand the motion of it. The level 2 consists of a grouping between like 3 or 2 facial parts. And the level 3 is an overall analysis of the facial's motion based on all the components of a face. So basically, the analysis of the motions goes from level 1 to level 3 in a way that we analyze the independent part of face, and then we analyze the emotions. However, when it comes to projecting the emotions to a 2D character, we do it in a reverse way. We consider emotions as one of the most important part of a 2D character's facial expression, and the subtle change of single facial part comes after that. So let's make a very simple example. For example, when someone is a live action person is giving an awkward expression, the face of that person could look like a smiling face, but the overall emotion is awkward. So if we only project the 2D animation in a way as a point-to-point projection, if we just translate every single facial part's motion to the 2D character, the result will look pretty stiff and unnatural. However, if we do it in this kind of, in our proposed way, we start from the emotions and the small changes came after that, we might be able to create a more natural and more organic animating result. So in our project, because we have limited time, we set our objective to completing the level 1's proof of concept by conducting facial landmark detection for human faces, analyze different facial parts, translate it to the data that could be understood by the master controller, and build that kind of connection between the mocap program and the 2D animation software. And ideally, the system should work in real time. And we need to have a calibration system for capturing 0 poses for different users so that it could create a more reliable 2D animating result for different users. And our progress so far is that we are able to accept user input bound values for different mouth poses. And we capture mocap data, interpret the data into meaningful motions, translate it in a way that the master controller could understand, and send the data to the widgets. And then we are able to realize this real-time controlling through motion capture to 2D characters. And for the system, we have 2 options. One is by using pre-recorded and translated data. And as you can see here, we are sending mocap data to the shark character. And the character is saying, "Hello, my friend." The second option will be using real-time motion capture. So by clicking the real-time capture button, we can use the mocap program to enable a real-time interaction between the user and the animation characters. So other than speeding up the animating process, the system will be also potentially applicable in different scenarios. For example, here is a video from one of my supervisor, Dave, And this is a project that I did when he was in Nickelodeon. And this is a VR interview of Ninja Turtle. As you can see, the fans are wearing a VR headset, and the fans is entering a 2D virtual environment with real-time Ninja Turtle characters. And the characters is actually talking to the fan. Well, the 2D characters are driven by puppet animation manipulated by the animators, and they also have voiceover actors doing the voiceover for the character. So the animators are taking care of the workflow behind the scene. And this is Dave. Pretty cool. All right. And in the future work, there's several efforts we can make. For example, add a calibration system for capturing zero poses and calculating customized threshold for different users. So our system is applicable for a wider range of users. Potential a system from sound recognition, just like the state of the art. The character animator also has this feature that use sound recognition module to help improve the accuracy of the lip sync translation. Data cleanup, it's a very important part of motion capture. We could add in some method to smooth out the motion curves and also getting rid of some unnecessary keyframes for less jittering and extreme values. Also, based on our proposed hierarchy, we can expand the facial parts analysis to higher level. For example, the level 2 and 3, the analysis of facial parts groups and the emotions. And finally, involving the animators. I think it will be a very exciting part to do if we can invite animators to test our system in the future and get their feedback from an animator's point of view. And finally, I would like to summarize the lessons that I learned from my internship with 3 keywords: communication, learning, and management. So communication comes first, because I think it's particularly important to make myself on the same page with my mentors and with the team. So throughout my internship, I found that understanding, so when I'm new to an environment, I think it's important to understand my roles and also other people's roles. And to achieve that, I chatted with different people in our studio from different positions, and also asked a lot of questions to them. I found this process particularly helpful because it helps me to understand what are the interesting possibilities in the industry, as well as getting to know new people, and also heard of many interesting experiences and stories. Get involved. This happened to me quite naturally because my mentors and my teammates, we share similar topics and interests, so it happened quite naturally. But I think it still will be very helpful if someone could be responsive in a team and also actively participate into non-work related events, because that's where you really get to familiar with people and share the progress of your project or your work actively with your lead or your teammates. Learning. So here I want to share an idea that I learned from our graduate professional development workshop that I found super cool. The idea is called Skills Translate. And the main idea is that same skill could have different forms in academic and non-academic contexts. So I think it will be very helpful for one to try to find the connection between your academic skills and the skills required in your work. So this will help you quickly understand what should I do in the work, as well as will help you quickly speak the same language with your teammates. Management. Even though I think even though someone is not in a management position, it's still very important to manage things, especially when it comes to work. Prioritizing is something that I felt benefited a lot throughout my internship because it helps me keep track on time and save me from a lot of anxiety. And project management, these 2 points are from the people that I talked to. One is from our line producer, and he mentioned that it's important to understand what are the various motivations for different people. And one is from our production manager that she mentioned it's important to pay attention to the timeline and budget. So I found that research and project management is also something in common. So I guess they will be helpful. So yeah, I think that's everything I want to share today. Thank you so much for your listening. And also I would like to sincerely thank Clue and Atomic Cartoons, and also all my supervisors and mentors in Atomic Cartoons, and also my supervisor, Professor Chris Jocelyn. This wonderful experience wouldn't have happened without any of them. Thank you all.